My name is Varun Srivastava, and I'm an undergrad research student at the Machine Learning Lab under supervision of Dr. Sujit Gujar. Today, I'll be discussing the poster titled Next Generation Blockchain, where we discuss how to achieve scalability and game theoretic properties in blockchain. So, what is blockchain? Blockchain is a distributed immutable ledger that is used to implement distributed trust. It uses incentive engineering to ensure correctness and cryptography to ensure security. The blockchain, in its current state of technology, faces three main challenges. The first being scalability. Blockchain suffers from a very low throughput. For an example, we can consider blockchain-based payment system Bitcoin, which achieve around 4 to 7 transactions per second, as compared to its centralized counterpart Visa with around 24,000 transactions per second. The second problem is fairness. As blockchain scales up, blockchain is shown to lose its fairness property. Another problem is reward mechanism. In Bitcoin and related uh, blockchain-based payment systems, block rewards half after every 210,000 blocks. As such, the protocol is proposed to move from a block reward model to transaction fee only model. However, it can be shown that there are rational strategic deviations in such a transaction fee only model that compromise fairness, security, and correctness. At Machine Learning Lab, we have proposed solutions to scalable blockchain, which include Ashra Chain. Ashra Chain is a blockchain protocol which achieves 300 transactions per second. It uses proof of work to mine blocks in the proof of work layer and distributed consensus mechanism in agreement layer to reach consensus on the state of blockchain. Similarly, Tiramisu is named after the layered suite. It is generalized analysis of layered blockchain and as to what parameters we can tune to achieve better performance. NIMI, which is based after the Olympian Muse of memory, is a blockchain which with capability of running on resource-constrained mobile devices. It uses proof of context for adding blocks in the blockchain and proof of equivalence to summarize data of multiple blocks into regenesis blocks, as shown by the image above. QuickSync uses concepts like block power and chain power for chain selection rule and histogram matching function to prevent Sybil attack. QuickSync stands for quickly synchronizing blockchain. The second problem was fairness in scalable blockchain. A paper published from the lab shows that blockchains might lose fairness at high throughput because at high throughput, faster and well-connected nodes might get higher rewards than what they fairly deserve. And if blockchain is not fair, then rational players will deviate from the longest chain rule, which might lead to undercutting attacks and thus compromise the correct functioning of the blockchain protocol itself. The third problem was the reward mechanism designed for transaction fee only model. So no blockchain protocol can achieve faithful implementation in a transaction fee only model, which is similar to the existing Bitcoin. As such, we proposed Bitcoin F, which is a modification to transaction fee only model of Bitcoin. It ensures that protocol still works as well as in the block reward model. In Bitcoin F proposes a minimum transaction fee for each transaction. Additional fee can be provided by the proposer of the transaction based on how urgent he wants this transaction to be accepted. There are two methods through which a miner can select transaction. First is from a queue, from which transactions are taken in a first come first served basis, and a pool of transactions from which any transaction can be picked. As such, a fraction f of transactions are picked from the pool where the block proposer or the miner greedily selects the transactions with higher transaction fee, and the other 1 minus f fraction comes from the queue on a first come first served basis. Other than increasing scalability and achieving game theoretic properties, we also analyze some applications of blockchain. Fast10 is a smart contract based blockchain voting protocol, which aims to achieve scalability to match real world requirements of voting and privacy to prevent tally leakage during voting. Other than this, blockchain based implementations have also been used for decentralization and anonymity of secure combinatorial auctions. Civic crowdfunding implementation is, is also done using smart contracts in a secure, reliable, and transparent manner. Thank you for viewing this presentation. Do check out our poster.